Hello, this is Kim Nelson. In this modeling tutorial, I'm going to talk about basic solids modeling approaches. Previous video I did was covering the basic swept surface commands in Rhino. This video will talk about solids modeling. The most fundamental aspect of solids modeling would be using geometric solids, primitives they call them. So, you know, sphere, center, radius. Another useful sphere is sphere diameter, which they have right next to it, where you define the sphere by its diameter, just like the circle curve commands. And the other one I find useful is sphere 3 points. And then the last one would be probably spheres along a curve. And I'll play with some control points to make that more three-dimensional. Not in any way a lovely curve, but it'll do. Three-dimensional curve. So, solid, sphere, a round curve. Select your curve, and then you can click, and you can make your spheres the same size if you want. Let's say 3 millimeter. And it will remember the last dimension you put in. Or you can do a selection visually. It's not making my life easy to select that. I'm going to go a little ways away. It's because I have an object snap on and the other spheres are close enough at hand, but it's trying to grab onto them. Okay. You get the idea. Okay. There are situations where that can be useful for jewelry design as well. Not many, but there are some. So that's sphere. Okay, so let's take a look at the next primitive that is commonly used, and that is boxes. And just like the sphere, this works like the curve commands do. You have corner-to-corner box. So you select the two corners, and where it's different from the curve command is that then you also select the height. Okay, another good one is doing the box. If you right-click right here, right-click box corner, box center corner height. I like that one. So then you draw the box from the center. It's also a curve tool that I like. I like drawing rectangles from center. So same functionality. Those two should really do it. There are other options, but they're not very effective. They're not very helpful. Yeah, diagonal, 3 points height, bounding box. No, this is enough. Okay, so those are your boxes. Ovoids. Ellipsoids are one of my favorites. And I just use ellipsoid from center. It's the only one I do. You can experiment with the others if you want. I find these very useful for control point editing to create quick forms. Like any control point editing, though, it's important to know where the edge is on this. If you select it, you can see that surface edge right along here. I'm going to want that on the bottom. It's going to be hard for me to select a seam point at the bottom because there's no geometry to snap to. So I'll do a section with grid snap. And now I should be able to snap to the bottom quadrant of this circle, of this ellipse. So, surface, edit tools, adjust closed surface seam to quad. Come under here, snap to that quad, and that'll drop that to the bottom. Because it's an ellipsoid, it's going to have very few control points. It's going to be a second degree, portions of an arc sort of form. All right, so not helpful for control point editing, but I can rebuild it easily enough by getting the little man with the hammer here or hitting F5, which is what I did. I think that 12 by 12 should be enough, both third degree. And that'll give me a more useful object as far as control point editing. And then to show how quickly you can create something here, I'll grab all of the top half points and I will project them to the C-plane. Delete input, yes. And then I can come in here and grab these rows, and I can do a non-uniform scale. Or a scale 2D, whatever your preference is, they work the same way. Same thing here. Then I can grab this series of points and another non-uniform scale, snapping to point. No change here now, so it's a 1. No change here, so it's enter. Here I'm going to bring that up. Non-uniform scale this row. No change in this direction. Subtle change in that direction. Grab this row of points, move it back, and non-uniform scale it. And you can see that very quickly here, I can create a spoon form. Takes very little effort to do. And so it's for exercises like this or forms like this that you can use that ellipsoid and quickly knock in forms. And I don't want to spend too much time on this. This was just an example of what could be done. And I'll flatten this out a bit. You really try not to mess with the ends, because if you mess with the ends, you can get a kink. So I'll mess with the points right before the end. Grab all of these, go to the right C-plane, do a rotation. Deselect this row of points, click on any of the points there, and do a counter rotation. Deselect these points, and do yet another. And as easy as that, from an ellipsoid I've created a simple spoon form. Okay, so they can be useful. Ellipsoid is one of my favorite solids. After the ellipsoid, really the cones aren't very useful. You can make them, but the problem I have with a lot of these commands in Rhino is control, right? I can do this, and I can do that, but how often in CAD modeling do I need this? You know, if I'm drawing a traffic scene, yes, or a hat for a clown, yes, but it's not a shape I need very often. But it's there. Pyramids are slightly more useful. You can set the number of sides to whatever you want. Okay, so there are some fun things you can do with that. This is a truncated cone, a truncated pyramid. Pretty self-explanatory. They both work the same way. Okay, it's set to 5. That's fine. And you have one more click that helps you decide how that top looks. Okay? It's going to work the same for the cone. Not something you use very often. Cylinder is exactly what it sounds like. Similar to its friend, the I'll move this back. Similar to its friend, the pipe. Not the pipe, I'm sorry. The tube. Pick a both sides option, and you've made a simple kind of ring. Not useless, but once again, it's not something you run into a need for every day. But there it is. And everybody's favorite, the Taurus. You run into the Taurus a lot doing tutorials online for doing rings, because it's an easy way to make a ring. Outside, inside. Okay, and then you can rebuild it so it has more control points. And then you can turn on those control points and you can do some editing to create some basic ring shapes. Okay. It is a popular tutorial online. Once again, it's not something that I am going to use in my working life. It doesn't offer enough control. But if you want to make something really quick to show your friends that looks respectably enough like a dome ring, or a soft sort of, come over here and grab these loops of points. Oh, wrong direction. You know, it doesn't take long to create something that feels like you've spent time on it. Okay. It gets more challenging with these rows of points because you don't have a C-plane set up to be able to scale those the way you would like to. So at this point, your symmetry becomes a challenge. Okay, there are ways to do it. It's beyond the scope of this video to go into that. There's really no point in doing it. You could do one side at a time, you know, by playing with a gumball or by setting up a custom C-plane. But this is actually the reason that I wouldn't bother. If I were actually going to try and use this in a fast sort of way, I would select those two rings of points once again. And I would delete, I would remove from the selection the top three on each side. And then I would move them up a little bit with shift. Okay, it's going to start making some strange things. It's not really controlled, folks, but it doesn't look bad, right? I mean, it looks like you know what you're doing. But yeah, no, this is not the way to really model a ring. But it is a quick way to create something that looks ring-like, that's impressive and fun. So that's a Taurus being played with. The last solid object I'm going to talk about is the pipe. Pipe is actually very commonly used. We use it for prongs, wires, jump rings, all kinds of things. Okay. So if I create a nice simple, what I would call like a prong wire, straight line here, rebuild that to 4-3. Now 4-3 is a marvelous curvature. You can't make an ugly curve with this. If you turn on your curvature graph, you'll see what I mean. It'll be nice and smooth. Okay. So, yeah, it's a nice curve. There's not much you can do with it, but it's great for prongs. So here you can make a pipe. You can get pipe from here. I tend to pull it off the menu, just out of habit. You can either enter a dimension for this top or just pick with your mouse. Click. If you just hit enter, it's going to accept that same radius as the bottom. And if you click again, it means you don't want another radius. Enter for none. And there is a basic sort of prong form. It's very useful to do this with history. Make something a little more delicate this time. Less delicate, whichever the case may be. I'm going to go ghosted so I can see the wire inside. I'm actually going to lock this layer so that all I can pick is the curve on the inside. With history attached now, I can grab these curves, these points, and do whatever I want to with them. And the pipe will update. Which is kind of fun. If I want to, I could then take this pipe record history, top C plane, and do an polar array. Let's say 8. See, that's kind of fun. Lock that again, and I can actually come in here and continue now to play with those points. If I wanted to keep them flat, I'm going to want to use the C plane I drew them on, so I can keep a nice flat curve. Unfortunately, when I did my polar array, I didn't have history. Well, because I changed C plane like that, which counts as a command and will cancel that history aspect. Okay, as we were. If I want it to go flat, keep that on a C plane. You can see you could create some fun things, and if you didn't want to stay flat on the curve, you could do that also. Right, so I can keep playing with that to get, whatever I might want to get from it. It's fun. It's playful. Once again, not something I use a lot in professional work because I don't have a lot of control over it. And I really like control when I'm modeling. I don't like any accidents. Okay? And it's cool how I can use that updating history to create this form. All right? And when I'm done, if I want to, I can Boolean all these together. And use a cutting plane to cut a flat bottom for it. And there I have some kind of jewelry element that I could use. Okay. So pipe can be very useful. Okay. You can do more with pipe than just simple straight wire. You can also do multiple widths. So once again, using pipe, I can start at the top. I can type in a diameter or a radius if I want. By the way, I can pick that. I'll make it a diameter, and I'll type in 1.5. And at the bottom, I'll type in 3.5. Nothing for the middle right now. Hit enter. And I have this very smoothly tapered wire. Okay. I can put an intermediate width if I want to. This time I'll do 2 millimeters at the top. And I'll do 2 millimeters at the bottom. And then I'll pick somewhere here in the middle, and I'll do 4. Right? It's pretty self-explanatory. I can, if I want to do regimented effects, I could set this up. Divide this curve by a number of segments. Let's say 6 or 7. Okay. I'm not sure if that's going to be a proper repeat. We'll find out. And do the pipe command. And make this top one here 2. And make the bottom one 2. And then make the next one 3. Make the next one 2. Make the next one 3. Make the next one 2. And I actually, I missed the point, so let's do it again. Because it is a fun exercise. I'm going to make it a little bigger though. So stop at this point, and I will make it 3 and 3. Next point, I will make it 5. Next point, 3. Next point, 5. Next point, 3. Next point, 5. And I'll make this 3. We'll have a little straight segment at the bottom because I didn't space out the repeat properly. And you can have this kind of a lumpy effect, right? Terribly useful? No, it's not. But there are interesting things you can do with it. So, if you record history, and do your pipe, start this time at 2.5, 2.5, and we'll go up to 3.5 and 2.5 And 3.5, you get the idea. There we go. I can, first off, I will throw away those points so I don't get confused. So select points, go to ghosted. I want my, hopefully that curve is a different color. Yes, it is. Good. So I can lock this so I don't select it accidentally. Turn on the control points again. And I can play with these points. And that same kind of knotty, boldy wire would work, okay? So, it's fun. Really only useful most of the time for a prong or some kind of more sophisticated motif. Okay? So, those are all of our principal solids. Okay? Spheres and boxes and a ellipsoid and a pipe, and a cylinder, and a tube, and some cones and pyramids, truncated pyramid, okay, and then our solid pipes. Oh, and the Taurus, which we stretched into a ring form. Okay, so that's the solids right here, the ones that you would use normally. Okay. By the way, there is an option of actually we'll talk about that later. Never mind. I don't want to confuse things. And actually, I didn't want to delete those just as yet. I will just turn off their layers and work with a limited color palette. I'm always in a hurry to delete geometry because I like to have lots of layers to work with. Okay. So now what I want to talk about is I want to talk about extrusions. Okay? Good way to start discussing extrusions is with a straight line. Important concept in Rhino. 2 words to really make sure you understand. And that is perpendicular and parallel. Okay? Perpendicular is the direction curves extrude from the current C-plane. Either one side or both sides. We never want to change the output here. We rarely want to change direction. This we will change frequently. This you never change. Keep that always delete equals no. These 2 things you will never use. So this only happens if it's a closed curve. So everything everything between here, these 4 options, 3 options, direction, both sides, and solid, are the only 3 you're going to play with. And since you rarely use direction, really the only 2 you're going to work with are both sides and solid. So that curve extruded perpendicular to the top C-plane. If I activate the right C-plane and extrude that curve, it will extrude perpendicular to the right C-plane. Technically, it shouldn't be possible for it to extrude perpendicular to the front C-plane because from the front it's just a dot. There's no information in that direction. Rhino knows that, and because it knows that, it protects you from yourself, and it will extrude it as if it were coming from the top C-plane. But it is important to understand this principle, what perpendicular from a C-plane looks like. Parallel to a C-plane is important in terms of drawing because, as you know, you can only draw on a C-plane unless you snap to geometry. Your next click, however, will be back down on the C-plane. The only place that doesn't happen is if you hit planar right here. If you hit planar, you snap up off the C-plane. Your next click will not be on the C-plane. It'll be parallel to the C-plane. And it doesn't matter how many times I click, unless I snap to something, those clicks are all going to be in a flat level plane, planar, to the current C-plane. Only way to get back down to the ground is to either snap to something on the ground or turn planar off. Okay, so parallel versus perpendicular. All right, perpendicular is what extrusions do. Now to show you that, because it will cheat for you for a straight line that's a two-dimensional curve, because it can figure out what you can and can't do. If I rebuild this curve, something a little more interesting, and I scale it up a bit, and I turn on the control points, and I rotate some points, to create something of an S-curve or a reverse S-curve. And then I take some of these points and I extrude them upward by using, move them upward, not extrude, move them upward using vertical C-plane. Pull that center point way down. So I have a truly three-dimensional curve. As you know, in Rhino, you can't really draw three-dimensional curves. You're always drawing two-dimensional. You can edit them into three-dimensional curves, which I just did, or you can use Rhino commands, like curve from two views or projections or pulling to get these three-dimensional curves, or blend curves will also give you options for three-dimensional curvature. But now I've edited this into a three-dimensional curve, we will do that same experiment with the extrusions. Top C-plane. Straight up, straight perpendicular from the top C-plane. Front C-plane. Straight forward and back, perpendicular to the front C-plane. Right C-plane. Straight side to side. Okay, so this shows you how important it is to know what C-plane is active when you are extruding, because you will get a completely different direction of surface depending on what C-plane is active. Except for when you use a closed flat curve. Let's draw a ring, shank. 0 for the center, diameter 17 millimeters because that's the standard. Offset at 2.5 because that's as thick as you want a woman's ring to be. Between the fingers normally, oops, come on, behave. And I should use the shift key when I'm doing that, otherwise this, never mind, it doesn't matter. Gonna offset this 1.7 because that's how thick you want it at the bottom if you're gonna do a casting. Move the outer profile up to where it touches using quad snap. Throw away the reference curve and there is a nice front view for a typical ring. Adjust the closed curve seam so it goes from the side to the bottom, and now you're in good order to model a ring. Fine. Let's talk about extruding these shapes. Because these are planar, which means flat, and closed, which means there's no opening. They're not really three-dimensional curves. Rhino can extrude these without you paying attention to the C-plane. Going to click that option for solid yes. Nice. That's what you would expect. The front C-plane is active. However, if I go to the top C-plane and I do the same extrusion, I get the same results. And that's because if you have closed planar curves, Rhino actually assigns a C-plane to them. They carry their own little portable C-plane along with them that you can't see, but that Rhino has assigned. So, to show you that in action, I will transform, rotate these. So they are no longer flat on any of our C-planes. They're not flat on top. They're not flat on the front. They're not flat on the right. So now when I extrude, since it's now quote-unquote three-dimensional and it's not flat to the C-plane, any C-plane you would think it would extrude straight up and down, perpendicular from the top C-plane, like it's supposed to. But it doesn't. These curves carry around their own C-plane with them because they're closed and flat. You can't access that C-plane, you can't see it, but Rhino carries it around with it. So if you have a flat planar curve, you don't have to worry about which C-plane you're in when you extrude. It'll always extrude perpendicular from the surface or curves that create your flat planar shape. Okay? So that's the basic principles of extrusion. Okay? When you do an extrusion, we talked about the main options you have. The only ones we're going to care about are direction, as both sides, yes, solid, and delete input. No, we're not even going to touch that. So it's direction and both sides and solid. Solid makes it a solid object. Let's take a look at direction. There's very little purpose for it, but you should understand what it is. If I click direction, I can click any 2 points, because all it takes to dictate a direction are 2 points. And Rhino will make that extrusion in that direction. Okay? It's very specific. You don't need it very often, but when you need it, you need it. Okay? So, let's talk about the next extrusion example we have here. which is extrude along a curve. So I'll make another wiggly curve. Okay. If I extrude these two curves using that command, I'm not going to pre-select. I'll just leave them unselected. Select curves to extrude, enter when done, select a path curve, and there you go. Once again, not something that's easy to control. Also notice the extrusion tries very hard to keep all of the cross sections facing front to back towards the same direction as the original curve. Okay. Let's take a look at how that would work differently if we did a loft. One rail. You can see here that it tries very hard to bend the cross sections to follow the curve, and therefore maintaining the same width. This is a bad surface because it overlaps itself in kinks, but that's because the diameter of circle is too big for the curvature of that curve, that path curve. If I use something that is a little more amenable, it'll work fine. Surface one rail sweep. It gives you the effect basically of a pipe. Whereas if I use the extrude along curve, you can see how it pinches here because it's trying very hard to, it's not trying, it's insisting on keeping all of the sections of that extrusion perpendicular to the current C-plane. Okay, so there's really not an instance where this is more useful than that. I'm always going to either use a pipe or I'm going to use a one rail sweep first to create something simple like this but much more predictable. So not a really useful command, but it's there. Okay, let's talk about extruding some other extrusion styles. I'm just going to draw an oval. That's fine. The next command is going to be a extrude curve tapered. And you can see that it does just what it says it does. This is an extrusion, but it's not straight. It has a taper. This, if you type in a number, dictates how tall it is. Okay? And usually what you want to change when you're doing this is the draft angle. To sort of change draft angle, you have to actually click on draft angle. And then you can type that. Type a number in there to make it whatever angle you want. You see it flips directions as you go past the curve. If this isn't the direction you want and you want the other direction, you can hit flip angle or F enter. We have the solid equals yes. Not going to change that. So that's how you use that command. Direction you're never going to use for this. Draft angle you will use all the time. Solid you will use all the time. Corners, leave the default, which is sharp. Delete input, you're never going to delete input, because if you delete input, you lose your curve. Curve is now gone. Okay? You don't ever want to lose your curve. Curves are more valuable than surfaces. So, back to the command. Flip angle you want to use. So on this command, flip angle, solid, yes, and draft angle. And or a dimension, if you want to type in a thickness. Okay? Useful. More useful than some of the other commands. Not something you use every day, but it is useful. This is actually very useful. Extrude to point. The challenge is you need a point to extrude to, because this does not obey a C-plane. It just wants to know what point you want to extrude to. So when you set this up, either go into a perpendicular C-plane so that you can then, pick a direction. I use this to draw the pavilions for stones, for like a quick maquette. So, in which case I would draw a straight line right down the middle, and then I can use that surface extrude to point command, and I can use near snap or end snap. To create a conical surface. All right, so that's how that works. Fine. So, ribbon. Okay, before I go to ribbon, I'm going to show you something that is actually another way of making a solid that's important to understand. I'm going to do a straight extrusion just to create a surface. If I want to create this as a thickness of metal, there is a command called extrude surface straight. You also have a long curved point and tapered options, which work the same as the other extrusions. Except for when you do this, when you extrude from this, actually I need to pick a C-plane that I can, that'll work perpendicular, because it's going to go perpendicular to C-plane. It's on the solid menu, because it creates a solid. You can create this solid object this way, but look at what happens. You have that same pinching. Okay? So it's not a great tool to use. There are uses for it, but you won't use it very often. What you will use is offset surface. These arrows tell you which direction the surface is pointing. If you type in a positive direction, a positive number, it'll offset this way. If you type in a negative one, it'll offset that way. If you make solid equals yes, and then type in a thickness, let's say 2 for 2 millimeters. That gives you that effect of a sheet of metal. So offset surface solid yes is a helpful command. It will not work for shelling complicated pieces. If you're trying to hollow something out, this is about the most sophisticated surface you can use for it, or a dome. It doesn't work with really convoluted surfacing. You have to use more sophisticated tools for that. But I will repeat it again because there is a step that's a little confusing. Offset surface. Okay, distance to blah, 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 blah. Okay. Solid equals yes. When I hit enter, nothing happens. To make it work, I have to hit enter again. And it's asking you to flip a direction, and that's why. I type in a dimension instead, it still wants to know what object you want to flip direction. Now, why it's using a flip direction command here, I have no idea. But you have to just hit an extra enter for it to show up. Unfortunately, that's what happens if you don't have solid equals yes. So it's an extra click than what you would expect. That's all. Okay, so I'm going to turn this into a 3D curve for our next demonstration here. To do that, I just need to get a vertical C-plane and move these up in the air in some clever way. Fine. So I can create a ribbon. Ribbon command. Once again, sadly, not a very useful command. But it is here, so I'll show it to you. Ribbon works like a three-dimensional offset. Like an offset curve. The difference being is that when you click, it's going to create a surface in between those two curves. It's going to be a very dense surface because offset always creates a very dense curve. And your surface, of course, inherits the DNA of your curve. So, ribbon, you can do both sides option. But in reality, when you do that, it creates two surfaces. To make them one surface, you would have to go to Surface, Edit Tools, Merge. Click both surfaces, and you have a merged surface. So now it's one, but it still has a gazillion points. So to make it useful, you'd have to rebuild it. Okay? It has 280 points right now. If I want it to actually just be a flat ribbon in its cross section, I'll change the U count from 3 control points to 2, and I will make this into a number that is not 280. For something like this, 27 should do. 25. You can see how much the surface changes in yellow, and it's changed almost not at all. That's a surface that you could edit, should you wish to. Okay. All that to say, how many times do I have this exact ribbon setup that I want to use? And if I do, how often do I want to create a surface that's not editable? And if I want a surface that's editable, okay, it gets tedious. But it's there. And it works. Next one is extrude curve normal to surface. We have experimented with this a little bit in other assignments. I will do it again here. Create an ellipsoid just as an object to work with. Move this into position. And project it. Delete input yes, because I don't want that anymore. And there's my three-dimensional curve. In this case, it's a closed curve. Now I can use this to extrude normal to surface. Normal is another great word to know for 3D CAD modeling. Normal means perpendicular. Perpendicular from that surface. So if I go analyze direction, you're going to see a bunch of little arrows. And anywhere I drag my mouse, there's going to be an arrow. And you'll see that arrow changes direction as it moves across this surface. Because what is perpendicular to that surface changes every fraction of a millimeter, right? So this command, extrude normal to surface, I'm going to put that on a different layer so we can see it separately. And a fresh layer for the extrusion. I can take this and I can extrude normal to surface. So, select curve on surface. That's our guy there. Select base surface. There we go. Pull it out to whatever you want and click. And when you're done, hit enter. This is tremendously useful in CAD modeling. Okay. I tried to trim that off and it wouldn't trim because Rhino hates to trim with surfaces. It likes to trim with curves. Okay. You can see how you could have a good time creating forms for jewelry using this. Caveats. When you offset a curve, when you project a curve, you get a very dense curve. Okay. When you extrude normal to surface, you get an even more complicated surface than you had in the curve. Because it's reading not just information from the curve, but the direction, the normal directions from the surface. That means this is not editable, really. It's not a very flexible thing to work with. If you want it to be editable, what you want to do is recreate it by duplicating the edges of it. You might also want a cross-section. And the easiest way to do that would be just to do section command using grid snap straight through. Got a couple of cross sections. So I can throw that away now. And because these curves came off of the surface that was extruded normal to surface, the surface that's created between them will also be normal to surface. But before I make that surface, I can rebuild. And for those, I would say I'm going to need about 36 points. That's fine. I could probably get by with 24. It's getting a little bit iffy at 24. So 36. And then I can try various ways of surfacing this. Because it's two closed curves, my favorite for this treatment, which is a loft, may not work. But we'll try it. I will put these seams at that curve. Don't know why it doesn't want to allow me. Yeah, it has very strong ideas about where it wants seams and doesn't want seams. But okay, I can hit OK. You'll see I'm getting some very kind of extreme angles. It's nice. It works. It is normal to surface. Bad place for a seam, but that's all right. I'm going to get a more dependable surface from bi-rail sweep. Rail, rail, section, section. Maintain height. Close sweep. And if I don't want the seam there, I can move it somewhere else. And this will have picked up should have picked up the cross-section, the control points from these two surfaces. It didn't. Loft will, so that's kind of, don't like where the seam was before, so I'm going to move the seam in the curves. It's right here. It's snapping to knots. That's why it won't go. Make sure that's always turned off. Snapping to knots is useless. It's completely useless. You'll notice these surfaces have different directions, these curves. One's going that way, one's going that way. Flip one of them. So they're both going the same way. It'll make your life easier. And now I can do loft. Fine. Okay. So, still more complicated than I would like it to be. I would have to rebuild the surface if I wanted it editable. This is a question. You keep hearing me say this. Editable, 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 editable. It's very annoying. I'm always, as I'm modeling, I'm asking myself, is this a surface I'm going to want to edit later? If I do, I'm very careful about the control points. I'm very careful about the grain, how these isocurves look. I wouldn't like those isocurves normally because they're pairing up in a strange way, so I would automatically rebuild this. I don't want to have 4 points across. I want it to just be more of a straight ribbon effect, so 2. 75 is an awful lot of points. I take it down to 25, that's good. Yeah, that's a better surface, right? So, I'm always asking myself that. And I don't move on to the next step of my modeling until I've decided what that surface is going to be, because this surface is going to be part of something else. Always, okay? So that's why I take the time to keep discussing that as I do the tutorial. So that's extrude normal to surface. Let's talk about solids functioning as far as the Booleans. Okay? We have 3. Union, direction, and intersection. Union, I'm going to go ghosted because it's easier to see what's happening. You can see that I have geometry on the inside of this. Some above, some inside. Boolean union will combine these objects and remove all the internal geometry. Select surfaces or polysurfaces to union. Do yourself a favor, always pick solids. Solid is not just these primitives. Solid is a geometric class. It means that a surface or a polysurface that has no gaps or holes in it. The beauty of using solids when you Boolean is that you will end up with a solid. Most of the time. If I come here to object properties, closed, solid, polysurface. That's what that P stands for. Okay? So, if you're going to do any 3D printing, this is critical. You have to have closed polysurfaces, closed models. That we use the term shell, like an eggshell. There's a blown out eggshell, so there's nothing on the inside. Okay? So that's Boolean union. Difference does the opposite. You select what you want to subtract from and select what you want to subtract with, cutters. You can either have delete input yes, which will make these objects go away, or delete input no, which will preserve them. I usually have it set to delete input equals yes, but it depends on what I'm doing. While this kept the internal part and removed the external part, it's still tight. There's no other non-joined, loose internal material rattling around in there. It's a nice closed polysurface. Okay. Intersection takes the interior parts where these overlap, and that's what's left behind. Select the first set of surfaces. Hit enter. Select the second set. Hit enter. And you can imagine that you can get some very involved forms from doing this. It always wants to overlap. It's never going to allow you to Boolean something that doesn't overlap. Just changing C-plane so I can move things up and down. Okay, so by the way, the color, the layer at the end, is based on the first item you select. So if I start with the cone, that finished object will be that color. Okay? It's pretty straightforward in concept. It's not a difficult idea. Just playing with this to create an object. Either a solid union or it could be a solid difference. In which case I'd probably want to move that up a little bit more, so that the prongs, the wires separate. Okay? That should be enough examples of how that works. Now, Rhino will keep telling you that you can use a surface to do Booleans with. You really cannot. Okay? The only Boolean function that works well predictably with a surface is difference. Boolean difference, cutting. Okay? And I'll say it again and again, in CAD modeling, the main thing you want is predictability. So even though you might be able to get to have an intersection work with a surface, first off, you're going to get an open poly surface. It won't be a solid when you're done. It's a dead end. But also the results will be unpredictable. However, let's say I want to use a surface to cut this. I'll just use a flat surface. Cutting plane. That's fine. Solids, Rhino knows the direction for. If I ask for a direction, Rhino knows that these are closed, so inside is inside, outside is outside. Outside, the arrows point away. You can't access inside because it doesn't exist. It's locked inside of this solid, very real thing in Rhino land. The surface, Rhino assigns direction to randomly. So that's the direction that it's pointing right now. When you use a surface to cut with a Boolean, it's going to keep whatever it's pointing towards and remove whatever is away from the direction it's pointing. So, predictably, if I do a solid difference here, It's going to keep these ends. If I want to keep the top half, I need to change the direction. To do that, I hit flip or F enter. Now if I do Boolean difference, I get to keep the part that I wanted. All right? That's important. The moral of that story is whenever you use a surface, before you Boolean difference and you're using a surface, check the direction of your surface. Make sure it's pointing towards what you want to keep. Otherwise, you can cut away whole sections of the model that were what you were really trying to work on. Okay? So that's Booleans. Last thing I want to talk about are revolves. They're right here. It's just one button. Revolve and rail revolve. These are the lathes of Rhino. So if I draw a quick form here. And either use trim or fillet set to 0 to tidy this up. Put in a center line and trim away what's left over. I can join these together. So I have a single curve. I can do a rail revolve. Sorry, a regular revolve, not a rail revolve. Regular revolve, click, asks for the curve to revolve, and it asks, enter when done, it asks for a revolve axis, which in this case is down the center. Doesn't matter where these two dots are, so long as they're in the center. And the direction I choose, I'm holding shift to make sure it's straight. First click for 0, second click for 360, and done. So any kind of lathed form you would want to create, this is how you can do it. You can change where that revolve axis is. And that will change the nature of your form. Okay, fun to play with. Once again, playing is good, but I'm also always about modeling to specification. So there are very specific reasons why I would use this command. And it would have to fit, what I'm trying to draw or what I'm trying to create. Obvious solution for what I've just drawn would be some kind of a vessel. I can explode this. Join these back together, do an offset to get a little thickness. Okay, it is set to trim, yes, it's just creating that extra piece for no reason. Which is okay, I can trim it away. I'm going to want a straight. Or maybe not, that's fine. Tidy up the drawing a little bit. And take this and do the same thing. revolve, revolve axis, straight up and down in the middle. And I've created some kind of a base. Okay. So lathe sort of forms is what you're going to use this for. Revolve, rail revolve, you can take this same shape and you can make it follow a path. I don't have enough points here to make a nice shape. But that'll do. I'll move this to where it lines up exactly with the bottom edge of this. Object snap with project, so it just moves it straight out. Okay. Find the center of this. Go into a vertical C-plane and execute the command. Rail revolve, right click, and deselect first. Select profile curve, select rail, axis, straight up, and there you go. So that can be powerful for creating forms. One of the most common uses for this in my jewelry work is a frame. See, I have some kind of frame motif. And I have a cross section I want to use. Okay, that'll do. Move that into position. And then go into a vertical C-plane and do that command with history. Rail revolve, right click. Profile curve, path curve, axis, a vertical. And I have a nice frame motif that I can use. And because history was attached, you know, I can play with this if I want to get different effects. Scale it in, scale it out. Rotate it. Okay. So that's what Rail Revolve does. So, folks, that really covers all the basic solids type modeling tools in Rhino. That's it. Between this video and the other video with lofted surfaces, you've seen really all of the principal surface modeling techniques in Rhino. Okay? There really isn't much else to show you. We have fillets. I didn't cover those. Solid menu fillet edge. Creates a round cross section at the corner. Like pipes, this can be done with multiple radius. So select handles to edit. You can pick one of these, drag it out, hit enter. Okay. That's fillet. The softer version of that is blend edge. Same thing. And instead of it being a hard circle, a crisp circle, it'll be more of a soft natural curve. Both are good, depends on what you're using them for. And then we have chamfer, which works the same way, except for instead of giving you rounded corners, it gives you a bevel. And that is it. And that's all we have. So thanks so much for watching, and I'll share more with you soon.